Howdy everybody in YouTube land. What we have in front of us today is an Apple IIe, if you couldn't already tell. So, you know about as much of this machine as I do at this point. Anyone watching this channel could probably know a hell of a lot more about Apple II than I do. Matter of fact, that's a guarantee. But this particular machine here, I don't know anything about it. I do not know if it works. I don't know of its history or any of that stuff. Now, this machine was a Vintage Computer Festival or VCF East 2021 acquisition in New Jersey, and I figured why not. I wasn't really in the market for the Apple II stuff. I'm not really an Apple II kind of person, but because of the price, I really couldn't refuse it. I'm thinking, it's worth a shot just to see, because the thing about the Apple II, I was in fourth grade, I think it was, when I first saw one of these machines, and it was in the classroom. And the problem was, I only used it a couple of times. The students really didn't get to interact with that Apple II very much at all. Teacher didn't have any lessons with it or anything like that, but I do remember playing with it during indoor recess a couple times. But it reminded me too much of my VTech pre-computer, so it was like my child brain was saying, this thing is a toy computer. So I never really got into the Apple II. I didn't really get hooked into computing until the following year, when there was a Power Macintosh 5200 in the back of the classroom. So that's when I really got captured into computing. But anyways, so this machine here, from what I can tell, well, first thing right away is, you can probably tell, is this is a Platinum 2E monitor, and this is a standard beige 2E. This is not a Platinum 2E. So the monitor and the machine don't even match. I would like to get the correct monitor for this machine someday, but right now this is what I have, so this is what we got. Now, it has both floppy drives, although the camera's not really picking it up very well, but the Apple logo on this one is a little bit more dull than that one. So it's kind of rough. And the other issue with this one is the screws are missing on that one. So I don't know what kind of fun we're going to have inside just yet. But other than that, the machine, it's got a little bit of key wear, but the machine is in relatively good condition. I don't see any major cracks or blemishes, just a little bit of scratching here and there. Nothing crazy, just it's a fine machine. It might be slightly yellow. The camera's not really picking it up that well, but in real life it's kind of more yellow than you would think. But it matches the disk drive, so maybe not. But anyway, so I'm going to pull this monitor down and get it out of my way. Get that out of my way. I don't know the operational condition of any of this. I've not plugged it in. But, see, no screws. So, I don't know what we're going to find inside of that drive. Kind of scary. But, anyways, I'll take a look at the drives later. This one still has its screws, so we know what drive or screws these need. So I'll set you out of the way for a moment. And I want to set you out of the way for the moment. Alright. So what do we got on the back side here? Well, we got what appears to be a printer port. So maybe it's got a Grappler Plus in it, and that's it. Pretty much no frills. So let's take a look on the inside. See what we got on the inside of this guy. Alrighty then. We have a few cards in here. What is this one? This looks like it says auxiliary connector. Again, guys, I don't know much about Apple II at all. I've not touched an Apple II since 4th grade, and that was back in 95. So it's been a long, long time. But 80 column. So this must be an upgrade for the graphics capabilities. AMI chips, proprietary. I don't know what they are. It's like they consolidated a lot with this board. At least the RAM is socketed, so that's good. But yeah, these are just full of Apple custom chips. Keyboard ROM. I don't know where the CD-ROM. Not the same kind of CD-ROM. IOU, MMU. Where's the CPU? There it is. 6502. Yeah, that's a classic. 19 day codes. 1986, 85. Well, this was made right around when I was born. So, this thing is as old as I am. 86, yeah. This thing is, yeah, it's as old as I am, almost exactly. So, let's see, what do we have in here? So, that is not gonna come out of the socket without destroying my fingers. That looks like the disc controller card. That makes sense. What is this one? Will this even come out of the socket? This must be the printer card. No, actually, that's a super serial card. So this has got a serial port in it. Well, that's handy. Because, yeah, that's about the only way you're going to get a program on this thing from, like, ADT Pro, I think it is. So, oh, God, what slot did that come out of? I don't even know. So, I don't think I just want to plug this thing straight in, because the issue here is reefas. So I want to pull this power supply apart and inspect it, check everything out before I just plug this thing straight in the wall. I really don't want to just plug this thing in the wall and watch it go bang. So plus I want to clean this thing out a little bit anyway. It's kind of messy, but alright, let's get this power supply out. I want to see what's inside there before I do anything. Pulled the drive controller card out, and that's a Jameco card, Jameco. I wonder if that's the same one, because I order from them all the time at work. I wonder if that's the same Jameco. It certainly looks like it. On the bottom side, we have serial number. So we have that. Suguyo! Actually, these things are fairly straightforward to take apart. And half the screws were loose, which has me slightly even more concerned. But I need to figure out how that plug thingy comes out. Doesn't, I guess it's a Molex. Yeah, it'd have to be. Yeah, alright, well that's out. Now, since I've not powered this thing up, anything I do from this point forward can introduce even more unknowns into the system. So, while we're introducing unknowns into the system, I wonder if I should just go ahead and pop all these chips out of their sockets and just deoxit them. I'm going to think about that for a minute. But in the meantime, I need to get that power supply out. I don't think they put enough screws in the power supply. They skimped out on them a little bit. They should put more. Alright, now that we got the lid off, we can take a closer look inside, and this thing smells bad. It's like a sealed box that's not, there's no fan. So, they probably just bake themselves to death. But let's see. No, I don't see any signs of leakage. 1000 UF 10 volt. Yeah, I can probably I got plenty of that stuff. So I can change them anyways if I want to. 680 at 16. I don't know if I have any of those. It's probably not critical, to be honest. Yeah, I got a bunch of thousands in here. 330 at 16. I got one of those. Yeah, I got a handful. 220 at 10. I got one of those. I don't have these 250s though. Anyways, does this thing need a refaectomy? Yep. Look at that little bugger. It's cracked too, so. Alright, this thing's gonna have to come apart. What's it take to get it apart? Screws are still intact, so this thing has never been apart. At least the board's never been out. I'm curious what kind of switching circuitry this thing uses. There's no label on that transistor. Is that an NPN, PNP, or is that an SCR? I don't know. I'm sure the schematics are available so I can take a look. But anyways, let's get this guy out. Now that I got the board removed, and these things are just so neat to how they're just like hand designed, these early boards. This was all done by hand on paper and then transferred over. It's kind of neat. Anyways, let's get Mr. Rifa out of there. I gotta see if I have another one in my stash. I should, but don't quote me on that. Alright, now that I got the Rifa out, you can see it's all cracked. And that's what happens to these. These things crack and they let moisture in, which causes the dielectric to break down, and then boom, these things explode. So that's gotta go. But I wanted to go over this power supply a little bit because this is an older design, but it's very similar to how things are done in a more modern sense. So the way this thing actually works is just like a modern power supply. We have pi filters. All four of these inductors and a capacitor on each side is a pi filter. This thing has 4 rails, so there's 4 pi filters here. So that makes sense. It's designed to curve ripple within a given frequency range. That's why there's certain values used, and that's why there's certain, that's why. You need the loop to keep the feedback network working. You need the loop stability in place. I noticed there's an SCR back here. This is probably a crowbar. So if this thing grossly overvolts, this will clamp hard, which will cause it to shut down. That's why when these are unloaded, they tend to go tick, 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 tick. Well, that's why. Because what happens is it'll overshoot and it clamps. Over clamp. So just whoomp, 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 whoomp. And that's kind of what that does. The other thing that's interesting about this power supply too is it doesn't use an opto isolator. Instead, it uses a current transformer. If you look very carefully, it's got 2 windings, and those windings are equal because this is a 1-to-1 current mode transformer. It's meant for coupling. It senses current over on this side, and then it regulates what's going on over here based on the amount of transfer going across this transformer. It keeps the 2 sides isolated. So this is before, optocouplers really became a thing. So they're using inductive feedback or transformer coupled feedback on that. So this is a self-oscillating design. So we have a transistor here, and then we have our main chopper transistor there, and then there's a winding off the transformer, and it just oscillates. And the frequency at which it does so is altered by this. So this uses a frequency modified regulation versus a pulse width modified regulation like a more modern power supply uses. So that's why the heavier the load, it'll start to downshift the frequency. So if you put a short here or a strong load here, that's why a lot of times you'll hear these power supply go wee, like in the audio frequency spectrum when they're heavily loaded, because it uses frequency to adjust how, you know, to compensate. So anyways, so we're going to need to replace these, even though they don't look like they need replacement. They're old enough now to where I'm just going to change them. You know, I don't, this thing is sealed. There's no fan or anything in here, so this thing gets baked. So it kind of makes me concerned with that a little bit. And they're probably within spec, but there's no guarantees, right? So I'm going to change them. Now, I don't know if I have these guys over here, because these are 47 microfarad at 250 volt. I got to look in my stash. I probably do have them, but they're not going to be a good brand. They're going to be those Honkoidial specials. So I may just leave those in there. I don't know yet. Another thing I noticed is there's an IC here that is all scratched off. So whatever they did, they protected the design by scratching that off. That's probably a TL431 shunt regulator. And that would make sense because it's going to set the set point to determine how much current flows through this transformer to regulate over here. But again, I've not looked at the schematic, so I could just be talking out of my ass. But judging based on experience from working on so many power supplies, yeah, I'm pretty close on how this works. So you got your 3 rectifier diodes here, and there's going to be a 4th one somewhere. Because, yeah, it's probably up here. Because we're going to have our positive and negative rails. There's 2 positive rails and 2 negative rails. So we got 1 up here and 3 down here that have the most current. Then we have our feedback path. There's our crowbar circuit, and then our feedback path, current mode, and then back in here, and this is the oscillator driver. Rectifier is right in here for the main B+, and this is the filter network. Now, since I work on and use AM radios, I'm definitely going to put a replacement in here. I can't just leave that out. So, I definitely have to do that. So, I'll be back in a jiffy after I get everything done. Pulled the first one out. Sure enough. What we got going on here? It's getting a light. See that? It's leaking. So, yep. Just getting started. So guys, if you haven't recapped your Apple II power supply yet, you better. Alright, so I got the secondary stage recapped. I got a cap in there. Now I'm down to these guys here. So what I did was I pulled one out and I checked it with my meter. And instead of 47, it's reading at like almost 60 at 1 ohm. So it's leaky, and it probably because it needs reformed. It's electrically leaky, but the ESR is okay. Now, I'm going to change them anyways. They're probably fine, but I'm going to change them anyways. However, once again, as normal around Tech Night Industries, I need 4, and I only have 2 left. I must have used them on the Zenith. So, once again, I'm going to do something that I highly recommend that you never do unless you really know what you're doing, but I'm going to use what I have on hand and do it anyway. So these 2 are in parallel, these 2 are in parallel. So I'm going to take a 47 and another 47 on each end, and I'm going to take these 2 and put them in parallel. Not going to be the same amount of capacitance. It's going to be low. I don't know 100% what's going to happen, but I'm fairly confident that it will work fine. So we'll just do that for now. At least until I can get these reordered and get some more in. I got some cheapos, which I don't want to use. Actually, I was wrong. They had to come out anyways. Because look, there's a lot of corrosion on those pins right there at the base where they go in. So these things had to come out anyways. They're shot. They're starting to leak. See? Yeah, that's a shame. So that's just it with these 2E power supplies. They have to go. All the caps have to go. And I hate to be that guy where I'm like Jason J.J. Cruz styling all these capacitors, because not always do you have to change all the caps, but it's getting to become more and more often to where I have to do that. But even more importantly, I only want to take this thing apart to take this thing apart once. I don't want to take it apart to take it apart again a couple of years later because the rest of them started leaking. I don't want to do that because that's just time. You know, and time is expensive, especially as you get older. And there we go. It's all done. So did the best I can here because these are in parallel. That's why I arranged them in this way. That should be fine. We'll double check, but it should work perfectly fine. Got the safety capacitor installed. All of these caps done. Everything's good. So we are ready to reinstall it back into the can, and then we're going to move on to the next thing. So the next thing on my list is to work with this motherboard. So what I want to do, actually I want to do a few things, but what I want to do is I want to pull all these chips one at a time, deoxit the sockets, and reinstall the chips. I want to do that first. I'm inclined to leave these axial capacitors alone because they almost never leak. At least I've not seen it happen. At least not on these anyways. So I'm going to leave those alone for now. But I'm going to reseat all these chips and stuff like that. The next thing I'm going to do is I'm going to resolder this video jack because looking at it, this is the same kind of jacks I see used on a lot of the older, cheaper car audio stuff, and these things go bad all the time. They'll get loose where the rim is crimped to this shield thingamabob, this mount. So I gotta sand some of that down and solder it in there. Then also, what I want to do is I want to resolder the solder joints here as well because they tend to crack and cause problems. All of these do. So I'm going to hit all that up. And then I'm going to reseat the sockets and then all of that. So let's do that on this board. And I want to clean this board up a little bit too. It's kind of nasty. And just like that, we're done. So the board's been cleaned. All the chips have been pulled. You can still see a little bit of deoxit left over. All the chips were clean, pulled, clean, sockets clean, deoxit, all in there. Resoldered this guy. Did the power supply. I got the 80 column card back in here, and that's all I got at the moment. So it's now or never. It'll either work or it won't. Let's see what the hell happens. No boom. No chingus out of the speaker either. So I thought these things beep. Could be wrong. Hey, I got power though. I don't know what's going on here. That's not lit up, but that may not matter. Okay, so let me oh, it just did something. It just did something. Alright, so let's just keep going. Let's put it back together. Let's just keep going. Alright, so I got the top all screwed back on and the keyboard connected just because I'm going to have to take this thing back apart anyways because I realized how nasty this keyboard is. So this keyboard's got to come out and I got to clean it. But before I do, I want to see if this thing still works because I got that weird high-pitched beep, 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 which might be because this wasn't plugged in. So let's find out. Yep, we're good. Yeah, I forget how this works. Yeah, that's fine. Bulb is out, so it's going to have to come apart anyways. Back off with the case. But hey, at least it works. So now that I got the keyboard out, I can kind of see how nasty it really is in there. It is, yeah, it needs cleaned. So I'm going to pull all these keys and clean them off. But before I do that, that's a light bulb, so it's probably blown. I got to see if I have one on hand. This is probably a 6.3 volt or even a 5 volt bulb. 5 volt bulbs are nearly impossible to find, but 6.3 volt bulbs on the other hand are something I can find all the time, and I probably have one somewhere. I just got to find it. So let's get that out and then see what we have on hand and see if we can replace it. Alright, so for now I got an LED in there. It's not perfect. I did some testing with this. It may or may not be bright enough, but at least it'll indicate. I'd like to find the original bulb, which they're probably made, but I don't know if they're made like this. the bulb will not come out of that plastic sleeve. I tried. It's like melted in there. So this went flying across the room. I had to go find that. But this key puller made quick work of pulling the keys out. But look how nasty that thing is. So I got to clean all of this. And then I got to clean all the spooge that are on the keys themselves. So, yep, just like before. Because, well, if you remember, I did the TI video where I had to rip the whole keyboard down and clean it up. So, here we go again. Wow, cleaning those keys were absolutely disgusting. Yeah, that's probably 100 years of accumulated dirt. So, yeah, that's garbage. Alright, so I love this tool. That made quick work of removing the keys. And then I used that to clean the surface of the keyboard, which is now sitting over here. Alright, not perfect. I need to go in here and still do a little bit more brushing. But not bad, because considering the chances of this keyboard ever of being cleaned is next to none. Especially if it came from a school, which is likely. So. There's crumbs in there. Anyways, you get the point. Alright, so we're ready to go start sticking the keys back on the keyboard. Now, I don't know if any of these key switches are any good or which ones are bad or not, but I guess we're going to find that out later. And there we go. That is much cleaner. Much better. Does not have that chow in there anymore. So now I can get this guy reinstalled back into the top case. The keyboard has been reinstalled back into the housing. Looks so much nicer. Now, this case is pretty yellowed, even on the inside. So, I don't know if this was natural, because honestly, I don't remember. I mean, you can see some imperfections here that are also yellow. So, this might be natural for this plastic. But honestly, I don't remember. I don't recall Apple IIs being this yellow. But then again, I've not seen an Apple II in the wild since I was an early child. So, it's hard to say. But judging by the lid, there's some dings on the lid. And you can kind of see white spots in the plastic where the dings are. So maybe this wasn't this yellow before. But I don't know. It's fairly yellow. Anyways. Enough of that. I'm going to go ahead and get this machine put back together, and we can move on to the next thing. So, moving right along, I think it's time to take a look at the floppy drives. So, I'm going to start with this one since there ain't no screws in it. I don't know what we're going to be dealing with here. I do not know much about these drives. I've never had one of these apart before. I don't know what the inside of a drive looks like until now. So, this is all new to me. Oh, that's cute. Don't know if the drive's any good. Don't know what's happened to this drive. Or its history. Or any of that. So let's take a look at the capacitors. See if we've got any leakage. I can't tell. Doesn't appear to be. These aren't even made anymore. Not from these companies. Okay. Ooh, there's a ton of them on a speed controller board. I hear stuff moving around underneath it. So, what I'm curious about, do these drives have belts? I bet they do, because I see a motor right here. So, Alright, let me get this thing apart and see what we're dealing with. Alright, I took the bottom cover off, and this drive has been shipped before. Because we got packing peanuts stuck to the... Oh, they've been there for a while. Like years. It stuck to... It melted itself to the metal. Really? Crazy. Alright, as I suspected, it is a belted drive. It's tough to turn. The belt is in really good shape. It's a fiber belt. It is. That belt is in really good shape. Nice. Alright, so... 12-volt motor. Makes sense. Okay, so... I'm going to go online and see if the belts are still available for these. I'm sure they probably are, but I don't know. But that belt is in such decent shape, I don't know if I'm going to mess with it. I'll see if I can get replacements though, but in the meantime, I think I should take this thing apart some more. See, that definitely looks like a motor controller, considering the motor goes directly into it. Do we have any signs of leakage? Actually, we do, with that one right there. Yep, so those caps are going to need changed. 1982. This is definitely not the original drive. 82. Let's see, what are these? 10 microfarad caps, which I'm pretty sure I have them. I'm definitely going to need to change those, because we've got some leakage going on right there. See the corrosion on that pin? It's got to go. So this will have to get removed and the caps changed on it. The mechanism's extremely dirty, so... And it's frozen. Yeah, it's not moving the arm assembly. So, alright, this thing's going to have to get torn all the way apart, and we're going to have to service this drive first, and then we'll do drive 2 afterwards. Now that I got the PCB off, a couple things apparent right away is, one, we've got solder joint problems with this one that I'm going to have to attend to, so we're going to need to work on that. But perhaps more importantly, this gear appears to move the head back and forth. Well, that's a problem, because it locks in there, but it won't. Yeah, so that's an issue. We're gonna have to really dig down into this thing and find out what we got going on in here, because something ain't right. As soon as I took the cover off, or the clamp assembly off, which is over here, and this is stiff, so it's going to need a little bit of grease, but these just kind of flew apart. I took the belt off, of course, but this thing just kind of flew apart. I don't think that's normal. Looks like it's been slipping for a while. It's supposed to be a press fit, where you have to use a tool to pull these. You can't just... That has me slightly worried. So... But there's bearing chases in there. There's like 4 bearings. There's 1. I see 2. Yeah, there's 4, possibly 5 bearings in there. So I'm going to try to trickle some oil down in there. I'm not making any promises, because the bearings can be ordered. I mean, the bearings still feel good, so I'm not going to do that. But you press them out from the top, because you see they're peened over on the top side, but not on the bottom. So you'd press them out, just whoosh, drive them. So, anyways, Yeah, they're not in bad shape. I'm gonna try to dribble some oil down in there anyways. I want to do the same thing with the stepper motor, but I don't want to move that stepper motor. I want to be super careful with what's going on here because there's alignment, which I'm probably going to need to realign this drive anyways, but because something's going on here, which I think might have been related to the clamp because now it's moving smoothly. Like I said, I've never worked on an Apple II drive before. This is my first one I've ever tinkered with. So it's a learning. This must be track 0 where it just. This gear doesn't have any oil or grease on it at all either. And it may not, it's also very nasty, and it may not require it. So I guess, do I put grease on it or do I not? That is the question, because I don't want to ruin this drive either. So I need to do some research before I start tinkering in something I don't know about. Alright, so I completely disassembled the drive. The head's removed. I cleaned this worm gear a little bit. And that should be good now, I think. I just want to make sure this thing is tight on the motor. Because the last thing I want is this to get loose because it's going to throw the alignment off. So that's cleaned up as best as I can. I cleaned all the residue off of this spindle, but I'm going to have to re-lubricate this clamp spindle because the bearing has seen better days and it's peened over in the plastic, so you can't remove it. I'm going to just have to try to lubricate that with my zoom spout oil over there and put this guy back together onto the clamp. In order to get this off, you just take this Jesus clip off and then you pull the spring and washer that sits on top here, and that goes right there. So that's done. I've got to try to get some oil down into this stepper motor. I want to get a drop or two of oil in there, but I don't want to remove the stepper because I don't want to throw the alignment off. So I think what I'm probably going to do is see if I can get that oil and snake the tube down in there and just kind of put a couple of drops on that spindle and just let it work down into the motor. So that's done, and I'm going to do the same thing here. I'm going to add a couple of drops on that motor. I'm going to add some oil into the bearings there and just kind of let it work its way in, and then we'll clean some of the residue up off of that. I can do a little bit better on that, and then start putting the drive back together. I gotta clean these rails off. I'm debating whether to put some lithium grease on that or not, because it doesn't look like this was lubricated originally. So the last thing I want to do is make this drive worse by lubricating something that doesn't need lubricated. So this almost looks like a Commodore head. It really does. Like a 1541. So I got everything cleaned up as best as I possibly could. I re-lubricated this and pressed it back together. Yeah, that's how it's supposed to be. Just barely. That's how it's supposed to be. Now that's good. This guy's all cleaned up now, so that's fine. Next order of business is to start looking at these caps, because I have one that's leaking and it's the only one that's showing signs of leaking, but I'm changing them all anyways. And then tack the solder joints. We should be good to go. And in the meantime, I'm just going to reuse this belt because I don't have the other belts right now. So we'll do that. I went ahead and took a Q-tip over there, and you can see how I have the holes cleaned out on that, got all the dirt out of that. I just have to clean the head next. But alright, moving right along. And there we go. It's all back together again. Now, of course, I got to take this board back off because I forgot to put that on there. But that's not a big deal. I'll pop that back off, put that back on. But anyways, so that's put back together. We may have to take it apart again to adjust the speed and alignment and all that stuff. I don't know yet. I haven't gotten that far because I'm going to need a diagnostic diskette to do that. But in the meantime, I'm going to wrap this guy up and I'm going to go work on the other drive, and I'm pretty much going to do the same thing. So we'll be back after both of those drives are done. So this one, I was just going to go ahead and do it without doing any video because it was the same as the last drive. But I figured I'd get some video because I ran into something here. See that? That's the right protect switch. The little lever is missing. So I guess this is going to be a read-only drive. Alright, so the last part of this adventure is I went ahead and got the disk drives. Drive number 2 wasn't nearly as bad. I didn't break it down nearly as far. I just did some light lubrication and head cleaning because I want to have a drive to be able to write a diskette in to realign drive 1 if there's a problem. Because right now I don't have any Apple II disks. So, assuming that drive 2 is properly aligned, who knows. But the write protect lever is missing, so that means it's going to be able to write all disks, including ones that are write protected. It doesn't care, so it is what it is. But in the meantime, let's take a look at this monitor. I want to crack this thing apart. Now, this is the wrong one. This is the Platinum 2E monitor, I'm pretty sure. But it's the only one that I have, so I am going to crack this guy open and I want to do an inspection because I already see some dubious activity going on, like that brightness potentiometer is just bent downward. So I want to crack this guy apart, see what we got going on the inside, and more importantly, check the health of the CRT because I want to know what it tests like, and I also want to know what the health of the capacitors are. So let's crack this guy apart and see what we got going on inside. So 2 screws at the top by the handle, and then there is a screw here, and then 2 here and 2 here, and the rear cover should remove. Now, this must have been the former owner. I don't know if that's C Knight or G Knight or whoever. That'd be funny if it was G because good night. Anyways, yeah, I'm gonna have to figure out how to get that off. Now, granted, this is on the bottom, so it's not visible anyways. However, I'd still like to be able to clean that up. But, alright, so, alright, she's coming loose. Alright, I'm going to need both hands to pull this. I got to fish this cable through, too, as I'm pulling it out. Alright, so now that I got the rear cover off, we can take a good look on the inside. Now, this is just a rebadged Samsung monitor, so it's nothing crazy there. She's definitely got some hours on her, because I can see a little bit of bluing in the cathode, and I'm just cleaning off the gun. And the dust built up around the high voltage lead, and oh, it's just so whittle. A whittle transformer. Anyways, 1987. It's the best thing I can gather now. So the machine was made in 85, 86. And the monitor was made a year later. So yeah, it makes sense because this is a platinum monitor. Anyways, I don't see any refuzz. I don't see any evidence of capacitors spilling all over the board yet, but I haven't pulled the board out to get a closer look. They're all Nippon Chemicon, United Chemicon, 85C, so we'll have to check. But I do want to test this tube, so I think it would be cool to find out what this tube tests like. So let me pull out the CRT tester. Move you off to the side and go grab the picture tube tester, which is over here at the moment. Just kind of like threw it in the way here. That will allow us to test and see what in hell and tarnation going on here. So move that out of my way. Figure out which one of these sockets is the one for this tube. I think it's 6, but it could be wrong. Ugh, scares me. Because I don't want to snap that thing. Yeah. Alright. Don't know if it's a 6.3 or a 12.6 volt filament. We're about to find out. It's 6.3 volt, which it's not a 6.3 volt filament. Or can't tell if that's, no, it must not be the socket. You can usually tell because the 6.3 is where the red tick is, right? There's not enough of a load to bring down the filament when it's plugged in, the thingamabob. So I say thingamabob, but really I mean CRT. Hold on, let me put the camera down because, yeah. Because I don't want this thing breaking on me. I see glow, but barely any, so I'm going to take this up to, 12.6 volts. So I'm pretty sure that is a 12.6 volt CRT. And I've already got emissions, but barely. So, alright, so 12.6 volts, 6, 8, 9, 12. 12.6 volts. That looks about right. That's about what we want to see. So 12.6 volts. No shorts. Set the gun balance. Alright, I got cutoff. So the cutoff is set here. Emissions. Oh yeah, that sucker's strong. Big time. Normal bias. Do the life test. Not great, but not bad. That's not bad at all. That CRT has still got quite a bit of life left on it. Do another life test. Yeah, it's fine. Still has quite a bit of life left on it. So, alright. Moving right along. Let's pull this chassis because I want to take a look at the capacitors and see what we got going on there before I just plug this thing into the wall. Alright, so I got the board out, and it's only partially out because this is a pain, but now I had to go back and do a double take because these are not United Chemicons. These are Samyang, which I've seen those before and much newer stuff than this, but with the logo, it's definitely a United Chemicon or Nippon Chemicon knockoff. But even with that, I went through all of these caps and they are not showing any signs of leakage at all. Now, that doesn't necessarily mean they are bad, but they're not leaking, so they're not an immediate concern. So I think what I want to do is I'm probably going to break this into like two parts, and I'll go ahead and get a parts list together for this board for the caps, but I'm inclined to leave them alone. The only concern for as far as the capacitors are concerned are this guy here, which is next to this heatsink, which this is the horizontal output transistor. So there's one right there and there's one right here that could just bake from the heat, and the same thing over here, but luckily they're far enough away I don't see a problem. The second thing is possibly this one here. This is a bipolar capacitor, and this is in the horizontal deflection yoke return circuit, which is very, very common with these small monitors. It's basically the one you replace with a film cap like this in the Compact Max. It's the same type thing. So I'm going to get a parts list together for this thing anyways, but I'm probably not going to immediately mess with it at this point. But I took a look on the bottom of it, and besides this one joint there on the flyback transformer, the solder quality on this thing is really good. It's impressive, to be honest. I might touch up a couple joints here and there, but other than that, this monitor really doesn't need any service. Now, again, I don't know if it works, but at bare minimum, what I'm going to do is get the deoxit fader lube, which is back there, and spray these guys out as well as that one, and probably leave it alone. And at least until I break it off into part 2 and, you know, possibly get the capacitors. I got to get belts anyway, so I got to get belts, and then I'm going to get the caps for this monitor. I'm going to write down the board revision and stuff like that in case there's variances. Matter of fact, I almost guarantee there's going to be variances because Apple OEM'd multiple manufacturers for their analog electronics. In this case, they OEM'd out Samsung. So this is a rebadged Samsung composite monitor. Anyways, so I'm going to go ahead and get the parts list together, get everything I need, could potentially need gathered up for the next installment. But for now, I'm just going to leave this monitor alone. Also, there is no capacitor list for this A2M6017 monitor. So there's a kit from some random website, but there's no capacitor list. So guess what? I'm going to go ahead and get this list gathered up, and I'll probably share it either on Discord or Twitter or something like that so everybody has it at least. Alright, so got my capacitor list together, which that's it right there, in case anyone wants to see it. Board information. And then I'm just going to juice it. It's either going to work or it's not. Alright, here we go. Nothing. No high voltage. Actually, no, it's on. Figured I'd hear the CRT charge, but I do not. So, do we have anything at all on the screen? No. I do have a light though. I do have a light. And I have a filament too, so we have that going for us at least. But no high voltage. I don't feel any whatsoever. So yeah, we might have to do some troubleshooting. First, let me go find a signal, because that might be what it is. I grabbed my high voltage probe, and it does have high voltage. I just can't hear it anymore because, well, I'm in my 30s now, and plus my hearing's been damaged from all the car audio exposure from 8-9 years ago. So, yeah. But it has high voltage. Because I just grabbed the probe, which is kind of like hiding over there right now. And it works. So, yeah, we're good. So we will get this put back together and get our machine set up so we can actually use it. We're about to wrap this video up. Alright, so now we are back together. Will it work? I don't know. Let's turn the monitor on. So, I'm not sure where that's supposed to be set just yet. Let's turn the power on. Thing's noisy. It won't stop trying to load. Oh, I can barely see it. Let's see. There we go. That's weird. I don't remember that. Turn the brightness up and it just kind of like smears out and gets dimmer. I'm gonna reset it. Alright. It's working. I am not an Apple II aficionado by any means, so I don't know how this is going to work, but it is on. Yeah, I don't know what I'm doing. Yeah, I really don't know what I'm doing. But anyway, so the machine's working fine. Now I just have to figure out how to make discs for it and test these drives because I don't have any. Anyways, let's do something fun. Let me reboot this thing. Looks like the keyboard works fine. Oops. Yeah, it's working. So oh, there's no backspace. Oh, that's new. Let's see, is that a bad connection? Nope. A little bit. Not perfect. But no, that's the vertical deflection. Oh, you know what? I cleaned these pots back here, so I bet. Yeah, that'll do it. Yeah, I sprayed the pots out. Alright. Yeah, here I thought something crazy was going on. Testing the keyboard. Seems to be working fine. Caps lock works. Yep, arrow key works. Up arrow does not. It's noticing that I'm pressing it though, so. Okay. Alright, well, I think I'm going to call it on part 1. Part 2 we'll go back and put caps in and all that fun stuff. But for now, the restoration series, part 1, is being wrapped up. So this was a fun little project. If you have a comment, please feel free to leave one. And don't forget to hit the like and subscribe and all of that fun stuff if you want to see more of this stuff in the future. But until next time, guys, thank you for watching.